So
This is the formula to start with.
yeah, it's fine. It's all good. We're gonna work through it together. But like that made me feel good, like, because that would make it even more just like a one-off random thing. So, which is what I want. So, here is where we left off yesterday. First, let's just do this little paragraph down here so we have this done. We did it. Capacity of buffers. So the capacity of a buffer is defined as its ability to continue to react with any extra acid or base added to it. The higher the concentration of the components of a buffer, the more it can absorb. Thus, the higher its capacity. So, remember, a greater concentration of one thing, you really want to have a greater concentration of the other thing to keep that ratio the same. Makes sense, right? The more ions you have available to eat stuff, the better the buffer is going to be. Okay, math. Here we go. Number one says a 0.100 molar solution of ethanoic acid, Ka, of 1.8 times 10 to the negative fifth, small ka, is mixed with a solution of 0.10 molar of potassium ethanoate. Give the pH of the resulting solution.
What the potassium ethanoate function as a base in this instance?
So this would be my acid, and this would be the salt.
Oh, the salt. Okay.
The acid and the
I
salt.
forgot that.
So if I was doing Henderson-Hasselbalch, right? If I was doing Henderson-Hasselbalch, that equation from yesterday, you would agree that my salt over my acid is going to equal what? Concentration of salt over concentration of acid. That's going to equal 1. Agreed?
Was that?
Huh?
Nick, if I remember it, you remember it.
Excuse you.
Henderson-Hasselbalch.
I thought you were. I was trying to get it as close to 1 as possible.
Well, this literally is 1.
Oh, duh.
Because I have 1 molar and I have 1 molar.
Yeah.
Yes?
Yeah.
So in the Henderson... Yes, but 0.1 divided by 0.1 is 1. Yes?
Yeah.
So if that equals 1, then this whole term technically equals what? What's the log of 1?
0.
Log of 1 is 0, which means pH equals pKa. Agreed?
Let's go.
So
Let's see it.
I need to get the pKa from this, which means all I have to do is do the what? Negative log of 1.80 times 10 to the negative fifth. So do that in your calculator, and you got it.
Who's gonna plug her in?
Who's going to do it?
I'll do it.
We're trying to do this in a half hour, right? Because of the
We got a clock.
We're doing.
Again, wishing
Yep.
you safe travels and good luck at your S&D.
Did anybody do their first 5 problems last night?
I was super
Good job.
busy and
What'd you get?
4.74.
4.74 is what I got. 4.74. So on this one, you want to try to use reasoning as much as you can and make these as simple as possible.
Wait, are today's periods shorter?
The morning is regular.
The ones in the afternoon.
The ones in the afternoon are shorter.
Does that mean period 4 is longer again?
Yes. Today, you go to 4th period regular, so you have 4 A, B, C, and then the special video is after that. So, number 2. That's good. Explain why it's a good practice when selecting a weak acid to make a buffer solution. That one with a pKa close to the desired buffer's pH is chosen. Why?
Explain what's good practice.
The wording on this is making it
Close to that desired, because it does, like, it won't. One with the PK close to that desired buffer. It just doesn't have to, like, for the. Is this only with, like, the midpoint or something?
The best buffers have what kind of ratio? Have approximately a 1 to 1 ratio, right? Of acid to salt. Either way. Doesn't matter. It's still 1 to 1. So,
Okay, so, oh, that's why you want, if you have the pKa that is close to the desired buffer's pH, does that mean it produces the right amount of salts?
right. So they can, remember how we talked about mopping up? So they can mop up slash absorb. So they can mop up slash absorb what is added. And if pH equals pKa, that means I'm at the, as Jack said, I'm at the midpoint, right? At the midpoint, what's equal? Your concentration of acid and salt. So when pH equals pKa, you are at the midpoint. Therefore, this term is 1. That's why. That's why. Did you watch yesterday's notes?
I watched 15 minutes of them.
Okay. Yeah, you gotta watch. Okay, number 3.
So what is it?
So they can mop up or absorb what's added. Number 3 is tricky. Number 3 is tricky. A certain biological molecule has an amino acid on its side chain with a pKa of 7.6. Calculate the pH that will result in 1/3 of its amino groups being protonated.
Immediately now.
So the first thing I would do would be write out my Henderson-Hasselbalch equation. That means has protons.
Oh.
Has protons. Before the protons are ripped off. So I know Henderson-Hasselbalch is pH equals pKa plus log. Now, before we write our term here, this is going to be on the top my deprotonated over my protonated. Are you guys okay with that? Because the salt has had the hydrogen ripped off of it. Yes?
Yeah.
And the acid still has the hydrogen. Are you guys okay with what I just did here? Yes? If I rewrite that, I kind of have everything I need. Here's why. pH equals, what's my pKa? They gave me the pKa. 7.6 plus log of, what am I going to turn this term into?
Is it 1/3 protein?
We know, yes, 1/3 is protonated. So if 1/3 is protonated, how much is deprotonated? 2/3. So what am I going to put on the top? 0.67. 0.67 over 0.33.
There doesn't need to be a variable in there, does it? It just needs to be
No.
1/6.
It's just 1/3, 2/3. It's just 1/3, 2/3. Solve it. That's it. So this one looked hard, but it really wasn't. It just took a little bit of reasoning about the protonated and then deprotonated.
7.9.
I got 7.9. I got 7.9. We good on that one? Yes? Number 4, you might be able to fit it in this space.
Oh.
I don't know. Yeah, I'm just saying I've got a lot of work on my number 4.
Oh.
So
Oh, I see why.
I just don't want you to be upset if you start it and don't want it in this space. I'm going to do number 4 on this piece of paper. Number 4. Ethanoic acid has a pKa of 4.75. So this is number 4. Find the pH of the solution that results from the addition of 40 milliliters of 0.040 molar NaOH to 50 milliliters of 0.075 molar ethanoic acid. Any ideas on how to start this?
No.
Okay, well, look at it. What would be a good first step? What could you solve? What could you figure out from this data that you're given?
pH of ethanoic acid?
Eventually.
Should we get it?
Eventually, we know we're going to be able to get that.
I see.
Before that.
Write the equation.
Before that. What can I determine from what they gave me?
You can undo the pKa.
Nope, before that.
write down Henderson Hasselhoff?
No. I love all these guesses, though. The first thing I would do would be determine my number of moles of acid.
Oh, yeah.
You agree that with what they gave me, I could do that?
They give molarity in milliliters.
Yes, they did. So my moles of acid is going to be 0.04, let's see, no, 0.05 liters, agreed? 0.05 liters times for every 1 liter, how many moles do I have?
0.075.
0.075 moles. So that will give me my, what?
Never mind, I just figured.
Molarity. That means I have 0.00375 moles of acid.
That's not a lot of moles of acid.
I'm going to do the same thing for the base. I'm now going to figure out my moles of base that I'm starting with. My moles of base is equal to 0.04 liters. And for every 1 liter of base, I have 0.040 moles. So from that, I got 0.0016 moles of base. So I have moles base, I have moles acid. Now, I'm going to write my equation.
Is that 0.04 mole?
Yes. So, now I'm going to write my equation. So, my equation in my R is ethanoic acid, which is HC2H3O2. It's just kind of a fancy name for acetic acid.
Oh.
Because eth means 2 carbons. That's all that means.
Oh, ethyl methyl. Oh.
Yes. Plus, what would you write next? What am I going to add to this?
The NaOH?
I am adding the addition of molar NaOH. So what am I going to write? What am I adding? I'm not going to write NaOH.
Oh, wait.
I'm just going to write OH minus. Why am I not writing the Na?
It doesn't matter.
It's a spectator, right?
Oh, is it? Oh.
We don't care about the Na part of that, agreed? The Na is not a mover and shaker in this. It's just the OH we care about. Yes?
Yeah.
You could write it if you wanted to, but I really just care about the OH ion. Is in equilibrium with, so the base is going to do what with this hydrogen? Rip it off and make what?
H2O.
H2O liquid, plus
Oh, is it just going to be
the salt.
what's it? Acetate ion?
Yes, C2H3O2 minus.
If we wrote the NaOH, would that mean that the salt would be NaC2? Like, if we included the sodium, would it?
Yeah, but
We don't need to.
we don't need to. We don't really want to. We just care about the ions. Initial. What is my initial amount of acid? It's right here.
0.00375.
0.00375 moles. What is my initial amount of base? 0.0016 moles.
Would that mean 0 for the one on the right?
Pause. Water, not part of it, right? And nothing has happened yet. So I have none. I haven't dissociated, I haven't reacted yet, so I have nothing to start with on the right. I want you to think about the change. What is your change going to be? It's not X, by the way. Ideas on the change?
No.
I'm working on it.
see.
My hint is think limiting reactant. Think limiting reactant.
I think the limiting reaction.
The limiting reaction is the hydroxide.
Limiting reactant is the hydroxide. How do you know?
Because there's less of it.
Oh, so is it minus 0.0016?
Yeah, because I'm going to use up all of the base. So my minus is 0.0016 moles minus 0.0016 moles. Water's not part of it, which means I have to be adding how much on the other side? 0.0016 moles.
What would happen if we tried to do this with a minus x plus x situation?
You wouldn't be able to solve it. You wouldn't be able to solve it because you already know how much is changing. So at equilibrium, I have to do a subtraction. You get 0.00215 moles. I have none of the OH, which is good. Water's not part of it, and I have 0.0016 moles of my salt. So check it out. I have acid and I have salt. Agreed? Not yet, though, because Henderson-Hasselbalch is based off of what?
Henderson? Probably not.
What has to go inside of those brackets?
Concentration.
A concentration,
Okay.
right?
Oh, wait.
So before Henderson-Hasselbalch, the next step is, what's my V total?
Oh, it's 90 milliliters.
My V total is 40 milliliters plus what? 50 milliliters,
Oh, then
which equals 90 milliliters, which is also the same as 0.09 liters. So to figure out my concentration of HA, that's going to equal, I'm trying to show all my steps here, the concentration of my HC2, H3O2, which is going to equal 0.00215 divided by 0.09 liters, moles per liter. What do you get there? What'd you get?
You're just typing a lot.
0.023.
0.023, I had 9 molar. My concentration of A minus is going to equal, in this case, C2H3O2 minus, which equals 0.0016 moles, still divided by 0.09 liters. Because a buffer is when you pour them together. That's why I'm adding these two. Does that make sense? A buffer, I have to add them together. So this is 0.0178 molar. Now can I do Henderson-Hasselbalch? I sure can. I have everything I need. pH equals pKa plus log concentration of A minus over concentration of HA. Sub in your numbers. pH equals, they gave me the pKa way up there. It's still 4.75 plus log of 0.0178 molar over 0.0239 molar. A good buffer, the pH shouldn't change that much. So do it. What do you get? Put that in your calc. .62. That's what I got. Yes, I got pH of 4.62. All right. Number 5 is just like that. Try it. Try number 5 on your own. That's why I said probably don't have enough space.
No, I said I do have enough room.
Oh, okay. I'm proud of you. I'm proud of you. I feel like that process, I really worked that out for you well.
Well, I never go to disappoint, so.
So we have to be done by 9:27. Oh yeah. We got it. I start my work? I guess far enough ahead? Okay.
Formula for methanoic acid.
It's HC, sorry, I should have given that to you. It's HCOOH. HCOOH. Methanoic is HCOOH. And you would not be expected to know that on the AP test. They would have given that to you. Because that's organic. Wait a second. Do you have .0025 or .025?
0, 0.
0025.
.0025?
For the moles, yeah.
I was talking about for the liters.
Okay, the liters, 0.02.
.025, right? Okay. Okay.
It seems I've made an error.
What are these numbers?
It is the dye effect. We don't.
Yes.
Two zeros in front of my one that I got.
Where?
For the equilibrium for the acid.
.0025
I am blind. I am.
minus .00239.
I'm wrong. I'm wrong. Forget it.
It is the dye rocket launcher.
Wait,
Take action
am I-
immediately regarding this individual.
Oh, so am I wrong? What are you
Talking about.
I got 3 zeros.
Yeah, I also have, that should be, for your equilibrium, did you guys have .000?
Yeah.
0, 0, 0, 1, 1.
And
Yeah, There's
Okay.
a lot of zeros.
Yeah, I did too. 0.00011. Okay. So I have 25 ml plus 23 ml equals 48 liters. Good so far?
Yeah.
I got that dog.
That's right. That H dog. H dog smarts. H dog knowledge.
Take the P over KI.
Is someone hacking over there? Have you guys got to the Henderson Hasselbach part?
Yeah.
Yes.
Which part?
Okay, I'm gonna pause.
What part?
The equation.
No.
Huh?
I'll pause.
Acid. Salt over the acid. Acid. Yes. Salt over the acid.
They started at rock bottom, now we're going deeper.
Oh, I used to helper.
Oh, we're at 28 minutes. This is perfect.
Wait, what? Huh? Wait, there's no PKA.
You have to take the P.
So,
You have to-
once you get to the Henderson Hasselbach, remember, I need the PKA. On number 5, what did they give me? The KA. So therefore, before you put it into the Henderson Hasselbach, you have to do what? Negative log. You've got to take the negative log of this. So I have to do the negative log of 1.6 times 10 to the negative fourth, which that gives me 3.79. Hopefully, if you start writing this down here, you're like, wait a second, this is going to be weird, right? So now I sub in my stuff. So I have 3.79 plus log 0.0488 over 0.00225. And that is my final answer. So make sure you are matching the right terms. Because it gave us KA, it did not give us PKA.
You won't get oh, let's go.
If you can do this, you can pretty much do anything.
Yay.
You can pretty much do anything. And that was 30 minutes, which is all the time I have, fifth period, which is perfect.